that integral over c dz upon z minus a equals 2 pi I, integral over c z minus a the whole raised to n dz equals 0, where c is the circle, modulus z minus a equals r, and n not equal minus 1. From the equation of the circle, modulus of z minus a equals r, we have z minus a equals r e raised to I theta, where theta ranges from 0 to 2 pi. When you take derivative on both sides, you obtain dz equals I r e raised to I theta d theta, treating a as a constant on the LHS and r as a constant on the RHS. Now, the given integral can be rewritten as, in the numerator, dz can be replaced by I r e raised to I theta d theta by this equation, and z minus a in the denominator can be replaced by r e raised to I theta. We can cancel e raised to I theta into r from numerator and denominator, and I can be taken outside integral being a constant. Thus, I times integral 0 to 2 pi d theta is obtained, which is 2 pi I. Z minus a can be replaced by r e raised to I theta. Therefore, z minus a the whole raised to n becomes r raised to n into e raised to I theta the whole raised to n, which becomes r raised to n into e raised to n I theta. Also, dz can be replaced by I r e raised to I theta d theta. Now, r raised to n into r can be taken outside integral being a constant. It becomes r raised to n plus 1. I can also be taken outside integral being a constant. Therefore, we have to integrate e raised to I n plus 1 theta with respect to theta. We obtain e raised to I n plus 1 theta upon I n plus 1 theta, to which we give upper and lower limits 2 pi and 0. When you give upper limit, you obtain e raised to I 2 n plus 1 pi. We have e raised to I 2n plus 2 pi can be expanded using Euler's identity, which becomes cos 2 times n plus 1 pi plus I sine 2 times n plus 1 pi. We have cos n plus 1 2 pi becomes 1, and sine n plus 1 2 pi becomes 0. Therefore, we have e raised to I 2 times n plus 1 pi becomes 1. When you give the lower limit, you have e raised to I n plus 1 into 0. E raised to 0 is 1. Therefore, when you give lower limit also, you obtain 1. Here I and I get cancelled, and n plus 1 can be taken common outside. So you obtain r raised to n plus 1 upon n plus 1, but here you obtain 1 minus 1, which becomes 0. Thus, we have derived the second result, integral over c z minus a the whole raised to n dz equals 0 whenever modulus of z minus a equals r.